I'm Brent Compton. I look after the storage solution architecture development team at Red Hat. I'm joined today by Stephen O'Sullivan, who looks after Vice President of Engineering at Silicon Valley Data Science.
That's correct.
How we got to where we are today is about 9 months ago, we were engaging with a large retail, household brand name retail company, as well as a large household name cable telecom company, large household brand name financial institution, and saw common trends as they were effectively shifting from their traditional HDFS type clusters into emerging architectures. And about the fourth time we saw this, we thought, we'd like to pull together. So I look after a team of architects. And that's one of the things that I like about working with Red Hat is people are generally fairly open to collaborations. We brought in those architects together, and over the course of about 6 months, say, let's examine your architectural patterns. What are you doing that's different from a classic HDFS architecture? So about 5 months into that, we decided to engage Silicon Valley Data Science to augment our big data, the Hadoop, Spark, Yarn, Presto type skills to augment our team, cloud builder type skills. And it all kind of culminated in a 2-day architectural workshop where we sat down, again, facilitated by Silicon Valley Data Science, with architects from these companies and say, let's sit down and examine first your architectural patterns, then yours, then yours. We had the 3 companies involved. Intel was with us as well. And say, let's look at the commonalities, and let's also look at where you want to go. And then my team looked to stand that up inside of a lab. The lab was a courtesy of Quanta Cloud Technologies. Provisioned in a lab, let's build that architectural pattern in a lab and then answer a lot of the questions. Because even though some of them were about a year plus into this architectural pattern, they still had unanswered questions. And so the purpose of this lab was to answer some of these architectural questions that I hadn't had a chance to answer yet. And that's kind of part of the journey that we've been on. So we're kind of reporting to you today a little bit of that journey. And so let's see, there's a clicker here. So we're going to kind of talk about, so if you remember 3 things architecturally, so this is kind of a lower level. If you remember 3 things architecturally from our discussion today, these are the 3 architectural patterns that we see emerging in very large big data shops. The first is the disaggregation of compute and storage. If you attended there was an eBay Intel talk yesterday about that exact thing. Again, this is in the context of classic big data, Hadoop, Spark type cluster. So that's key takeaway architectural pattern number 1. Number 2 is this notion of many to one, so many analytics compute clusters sourcing and syncing from a single common object store. That's the second architectural pattern takeaway. And the third is on-demand ephemeral compute. So for the data labs, the ability to spin up ephemeral analytics clusters becoming more and more in demand, being more responsive to demands from data laboratory requests in-house, having the ability to give them on-demand provisioning capabilities for them to provision on-demand the infrastructure required for their data science, for the data scientists to do that. So kind of 3 general takeaways from an architectural pattern standpoint. So that's the kickoff. So the bulk of the time we thought we'd have, again, Stephen, so Silicon Valley Data Science, they're a professional services company. They consult all over the world, helping people effectively design their analytics, not only architecture, but also analytics, algorithms, et cetera. So we thought we'd invite them in to talk to you to kind of illustrate to you what they're seeing as they travel around the world. So the bulk of the time will be spent by Stephen. And once Stephen wraps up, then I'll kind of talk about how to instantiate, how some of these early adopters are instantiating these architectural patterns with Red Hat technologies. Stephen?
Thank you, Brent. Right, so as Brent said, I'm the VP of Engineering over at Silicon Valley Data Science. My background is I was at one of these large retailers. I was at Walmart Labs for about 2 years. I was leading out one of their big data platforms. Before that, I was at a startup. I'm in Silicon Valley, so you got to do the startup thing at least once. I'm now doing it twice, but you do it at least once. Before that, then I was at Yahoo. I was in Yahoo Search and Search Advertising. When I was at Yahoo is when I got into Hadoop. I'm an Oracle guy, version 7, version 7. Version 5, all the way through to version 11. That's like kind of my background. Got into Hadoop because Doug Cutting was doing Hadoop. They were doing stuff in search. I need to get data from search. They said, hey, it's in this HDFS thing. Go pull it from there for your Oracle database. And then before that was Sun Microsystems. But the journey that we're going to talk about is this big data platform. How do we start? So normally, a lot of us have started here. And mind the crude illustrations. My 11-year-old daughter helped me with them at the moment. So she's the one who found them on the web for me. So where do we normally start up from an R&D hobby? So we hear this thing Hadoop. We should try this thing called Hadoop. The first thing we do is, I need some servers, and there's no way that I'm going to get any servers from my IT organization. So what you do, you get a group of people, you find a few desktops, you put them together, they're under someone's desk, and you network them up. The things that you're trying to do here is, you're looking at small amounts of data. What do these things do? How does it work? How does it interact with each other? What can I do differently to what I do today? How can I do these things like, hey, I can do things like word count that can be distributed, which is the first program that anyone runs is the word count program in Hadoop. How does this work? And then you start learning all these new toolkits, and you realize, hey, there could be a there. And for me, that there was, I can take all of my ETL that I do in Oracle, this is way back in 2005, and I can do it in Hadoop, and I can do it cheaper there, and I can free up my resources in Hadoop. And that was my use case at that point. When we're looking at it, we're looking at really small data sizes, like 500 to 100 to 500 gigabytes. And cost is either going to be like 500 to 3K, and I'm not paying for any license cost at this point. I'm pulling down Hadoop from either one of my distros or pulling it down from Apache, depending on how I feel and how much I understand the technology. And that's pretty much what we're doing. We're basically learning the techniques and some of these skill sets. Then we're going to start cooking with gas, right? We've got an idea of a steel thread, a use case that we want to go and do. Let's say that use case is, I want to move ETL, or I want to look at some analytic information that I can go do that currently today, my enterprise data warehouse won't let me do because it doesn't have the fine-grained piece of information. So a good example of this is from my days in retail is, I want to look at doing shopping basket analysis across all of my stores, and I want to look at every single item that's in every single shopping basket to get an idea of what's the trend of things at certain points in time, right? Most cases in an enterprise data warehouse, we're rolling some of this information out. We're not getting down to the fine grain. I'm getting a product. So we've got our use case. So with that use case, I go and ask for some budget. And they go, well, we can't really give you anything. What we're going to do is we're going to give you a few servers in our non-production dev environment, where at that point it's oh, God, yeah, those really old servers from a few years ago. They're not going to run, but we go try it. So we set up these servers. We're only going to store the data we need. So we're not going to stream any data in. We're just going to get let's go and get 2 years worth of data. Let's load it up. Let's see what it looks like. I may come back and load some more information. But pretty much, I'm getting on the idea of I got some grips, got some ideas of what I want to go do. Then I start using this to process the data, and it's been fairly successful. What we're looking here is probably 1 terabyte to 5 terabytes of information, depending what it looks like. We're going to have to may need to buy some new networking gear, so anywhere between 5K and 20K. But again, still no licensing cost. Right, I'm not spending any money on licenses. I'm using what we currently have. And of course, I'm obviously working out with everything else that's running in these racks. And it's like, okay, we've got some results. What's the next step? Yes, we're in production. We can actually create a production cluster. So we're going to go, okay, well, what do we want to do? How much data are we going to get? For that one use case, we want to go in production. The things that we forgot about in the POC is I didn't do security. Oh, I should have done security right from the beginning, because it's a real pain in the ass to do security in Hadoop. Trust me, it's a pain in the ass to do security in Hadoop. And then how do I encrypt it? And then networking and getting all the machines into your data center. And I was one of these people that I got sign-off in, when was it? In June, I got sign-off on some machines. Great. They were delivered in July. They sat on the dock for 8 months before they were put in the data center. So by that time, this new equipment that I got is now 8 months old before I even get to use it. So we set up all the bits. This is great. We're putting some data in. kind of things that we're thinking about is, all right, so I now got to start streaming this data. Oh, I wish I did some of that streaming technology back in my POC. Things that you can learn. So I'm in production, we're getting some operational support. The thing that I have to do now is I've bought some machines, 500K, maybe a little less, but it's the licensing cost. Anywhere between 4K to 8K per node for licensing costs from your favorite distro, Cloudera, Mapr, Horton, etc. I want to get the full data. I've got the full data set in just to ingest that. The full data set for that use case, and I'm obviously still ingesting stuff through the stream. So this is coming on pretty well. I've got a support licensing agreement. This is really, really good. Okay, and then we can go victory, or is it just the first hurdle? We're very successful, everyone high-fiving everywhere, and then you get the question, because all of a sudden there's one organization that's in Hadoop. You get can we be there too? And then all of a sudden I've got 20 people at my door saying, can I be in this? Can I be in this? Can I be in this? And you get the, please sir, I want more. And then all of a sudden it's oh yeah, so you got transaction data for 2 years. Can you get it for 11 years? Oh yeah, now we've got some other devices in the store that has IoT and we want to stream that in. Can we get that in? And all of a sudden you're oh crap, we're going to run out of space and I need to add more nodes. And this is great, but we got success. And then all of a sudden you get the data scientists come out of the woodwork and say, we want to use this cluster because you have all this data and we want to run this query. And they run their first query and all of a sudden your production SLAs basically hit the floor. Everyone's screaming, it's month end, and we're all running around on a hair on fire because one of your data scientists, who's one of the brightest people in the room, goes and runs a query that uses up every single piece of the processing power that you have on the node. And you're running production in there as well. Okay, so I need to add more nodes, and you go back, I need to add some more nodes, and looking at where we are, we need to add probably 5x, well, let's go for 10x, and all of a sudden you get this shock of, well, I know how much it's going to cost me from a machine standpoint, and then no one's cutting you a break on license cost. And all of a sudden your license cost is going up and up and up, which kind of makes sense. But then the question occurs, do I need all that compute for all that storage? Right? So you kind of sit there and you think back, well, hold on, do I need all that compute? Because are my data science team running 24/7, 365 days a week? In most cases, we would like to say yes, but they don't. And do they need all that compute power? Do I need all that compute power in my production environment? And oh yeah, I got two organizations that they really want their own environment because they're used to their own environment, but they're sharing some data. And if we put them all in one, one's going to get upset because their job isn't finished before the other person's job, and how do you schedule all of this stuff together? And you just sit back and think, could we have a storage system that we could have that we can then just bring up nodes that can go and look at that data in that storage environment? This is back to the days I used to use SAN and NetApp a lot when I was at Yahoo. And go and pull that in and use it in the cluster. And if I'm a data scientist, I can bring up a cluster, do my work, and then shut it down again. And then the cost should be less, or I can provision a whole load of infrastructure to go do that. And if I have different groups, so for instance, if I'm a retailer that also has a bank, the bank can't see everything the retailers can do, and the retail can't see all the banking customers, but we do share some data, and we also want to sit in the same infrastructure. I don't want to have separate data and moving data around all the time. I wonder if I can just bring up 2 Hadoop clusters that way. So this is what we're seeing now. And to Brent's point earlier on, we disaggregate the compute and the storage. We independently scale compute and storage. To control, there is no license, well, I'm going to say there's no licensing cost from a Hadoop standpoint on the storage if you scale it that way. Obviously, depending on if you get licensing from whoever your provider of your object store is a different matter. But from a Hadoop standpoint, there's no license fee. Flexibility, and you can have it in the different data centers, so you can have your storage layer in the data center. I can do the same thing in cloud with the regions. The idea of ephemeral data labs for exploration of data science work is very key. If I'm a data scientist and I have a problem I want to go solve, I can spin up a cluster and spin it down again. But if I have like, oh, we've got to go reprocess a whole lot of data, not really a data science thing, but we want to reprocess some data for whatever reason. I think we've all been in the room when we've heard we need to reprocess that. Imagine if I can spin up a cluster that's quite big to reprocess some data, to do it really fast, to get back to going back into production again and spin that down. All of a sudden, I'm taking it away. Okay, may have not upset the data scientist a bit because all of a sudden they can't do what they want to do for a day because I'm using all the compute resource, but I'm using it for one day and I've got it for one day. Or I'm a retailer where previously what we had to do is provision all of our processing power and storage for 4 weeks of the year. So come the middle of the summer, I may not need all the compute power I need on a Black Friday. Well, what if I could actually spin up what I need for the 4-6 weeks from a holiday season to meet the holiday demand and spin it all down again at the end? And from my cost standpoint, it costs a lot less. The other one as well is we can store this data in an object store. I don't always need Hadoop to access that data store. So coming back to my data science friends, some of my data science friends are also really big SaaS users. And if you've ever been a DBA and you've had SaaS users, you may not like the SaaS users doing a select star from your biggest table to pull it all into SaaS, to do some processing, to write some results back. Well, what if you can say, hey, Mr. SaaS user, why don't you go and put it from the file system? You're going to get it faster, and oh, by the way, more my other users of my Hadoop cluster or my enterprise data warehouse aren't going to hate you. And you can get it faster, do what you need to do, and everyone can see it. So we can actually have this storage that can be used. And obviously we have security and governance and all those kind of good things around it. So one of the things that we're seeing, this is something that I've put together. I've actually anonymized it a little bit. We actually was doing this with a client, which I will talk about a little bit later, well, later, 2 slides time, where we've had multiple analytic clusters with a unified object store. So the idea is, this is my processing set. This is my Hadoop, and I can have more than one. This is my data labs, and I can have more than one. And in my data lab, I also have, as well as having Hadoop, I have my data science toolkit, and I have different types of query engines that I can use to access this data, and everything accesses it. Any data that comes in through a distributed message broker, I put it, in some cases, it may go in a little bit of HDFS up here, but it all goes into my object store. And the reason for that is everyone can see it. So we have read-only copies of data where we need to copy data, and that's for lineage. Lineage is very important. I hate saying the fact that lineage is always important. It's becoming my mantra at the moment. Because that way then people can say, well, what if that data changes? If you have lineage and you know that's a read-only copy, that data won't change. Saying that if someone pulls it down to their own Microsoft Access database with Excel, all bets are off at that point. But hopefully that will work. You've got the ephemeral on-demand environment. So if I need to bring up another environment, I can. If I need to do disaster recovery because some nodes have crashed, I can, and I can reload that data if necessary. Ideally on my object store, I can move that across multiple data centers, or if I'm in the cloud, multiple availability zones. And it's done for you. It's going to expanding that picture a little bit. I know it's a bit of an eye chart for most people, but what we're seeing here, we kind of talked about all of this bit. But what we're also seeing is our data warehouse, where normally I was doing my ETL in. Well, if I do all my ETL over here, and I have data that I can then just suck up into my data warehouse for all my business BI users to go use for day-to-day reporting, all of a sudden, I've lowered the amount of resources needed in my data warehouse, so I can do more in my data warehouse than I could do before because I've moved it out. I can bulk out data if I want to. I can get my SaaS users can get it from my object store, my data warehouse, or even Hadoop at that matter, but why not just get it from the object store? Everything is still coming through the message bus or I'm bulk loading. These green things are basically saying data lineage and data dictionary. I capture every single change that is going on. And then obviously we've got security on top of that too. So what's possible? So we have a client in the UK, which is a large grocery store. Grocery stores in the UK apparently collect banks as well, so it's a grocery store with a bank. One of them, their main things were 2. 1, understand their customers better, run their stores more efficiently. They're challenged. Not all the data was captured or was being deleted quickly. I remember having a conversation like, so you get this data coming in, can I query it? Oh, no, we delete that. And I go, why? Well, we have nowhere to store it, right? The other one is data silos. No central view, lots of different technologies, little communications, groups not talking to each other. A lot of that is because they have no idea what data assets they have. And they're in different silos to even get them. And we had a data scientist that I met who's actually leading up that group. The first time I met him, he was a very happy Irish lad, really happy enjoying his new job. I met him 3 months later. He was very sad. He hasn't got a piece of data from anyone yet to actually go do this data science thing that they've spent a lot of money in hiring this guy to do, right? Because he couldn't get access to the data. He had to ask every single, can I get access to this? Can I get access to this? Can I get access to this? It wasn't in a central place. Solutions, unified platform, metadata, and lineage. Kind of important when you're with a bank, even with different data governance and laws within different countries, lineage is really important. Data is consumed not just by the BI, but data scientists using different types of tools, right? Traditionally it was the EDW using BI, be it, dare I say, business objects, those kinds of things. But now we've got things like we can use Hadoop, we can use Spark, we can obviously there's stats, etc. Results, no waiting months to get access to my data. Company-wide data catalog with all data assets in there. Obviously, you've got to have permission to see certain data assets. Effective cost control means ability to store data for longer periods of time. The other important thing that I don't have on this slide is in the UK and in Europe especially, as a consumer, I have the right to be forgotten by a company. If you have your data in multiple silos, that work is really, really hard. If you've got it in one place, it's fairly straightforward to cut the tie between how I identify that piece of information to a consumer. Then obviously think of all the data protection that's coming in as well. The other one is a large global retailer or a major global brand up in the Portland area. Again, they had the same sorts of thing. They had different data silos. Those were mainly in Oracle. They already had an on-premise Hadoop cluster with a limited data set because it was oversubscribed and they weren't going to grow it and it was too expensive to grow in the data store. In the end, in the data center, in the end, they went to the cloud. The data was also held hostage by third parties. So think of clickstream analytics going through and it's being stored somewhere else and you have to pay to get the data. Why do I have to pay to get my data? Or I've got to pay to get a new report and I can't get access to it. Certain customer data sources were being captured but were difficult to use because they didn't know how, in some cases, what the information was, what the metadata was, how to use it with other people. Different teams needed access to data in one place. So we had multiple teams that would get information coming in. They didn't want to go to multiple silos to do it, or they'd do it themselves. Solution. In these cases, they moved to the cloud, and all data was persisted in the object store. They had analytical Hadoop clusters that in their case, they had one Hadoop cluster for the data scientist, but all of their ETL and all of their batch jobs or real-time jobs, they span up EMR clusters and span them down when they finished. Configurable framework to load and transform data into end-user reporting clusters. So they had all the data in one place. They could actually run a job to get that information and then push it into things like their enterprise data warehouse or Redshift. Or in the case that they went to also is Snowflake, where all of a sudden, because their data was in a distributed store, they could actually put that data also into another distributed store, in this case Snowflake, to get access to it, because they've done all the work before, and it's just a matter of copying the piece of the data into what they needed to get into. A frictionless environment for tools to move data science insights to end-user reporting, which is key. So you've got these expensive data scientists creating some, I say expensive data scientists because that's what we do too. Whoops, shouldn't have said it that way. They're creating some really cool algorithms that's working. They want to get that into the business. How quickly can I get that into the business so the business can see the reporting from that? Or things that they can change how things come in. So think about, I've got clicks coming in, I can do some analysis on that, I've got some sentiment on that, and you can hear about, oh, something isn't working quite well. The example of that was literally today. I had a somewhat bad experience at the hotel across the road, and I tweeted, the guy at the front desk wasn't very nice. And in 12 minutes, I get a phone call from the manager of that hotel saying, your room is now ready, sir. Amazing. Kind of impressed. 12 minutes is pretty cool. I'm pretty sure that they have some stuff understanding the sentiment of people's tweets to know, oh, that person there has, dare I say, has some status. We should contact them because they're a good customer. And oh, by the way, it looks like they've got like 13 bookings for the next 6 months in our hotel chain. We should do them some nice service and get back to them quickly and get a room. The other one is I can spin up additional compute environments when I need it. We've kind of talked about that before, the idea that I can spin things up when I need it. With that, I'm going to hand back to Brent, who will take it the rest of the journey.
So this is about 7 minutes. We're going to leave about 5 to 7 minutes for questions, so be thinking about questions that you might have. So the last little bit here is, as we look at some of these early adopters, what kind of Red Hat technologies are they using to instantiate this architectural pattern? So the architectural pattern that Stephen talked about, this is a dramatically simplified version of the slide that Stephen showed before. So this is on your left-hand side. This is kind of back to the case of lots of different Hadoop HDFS clusters for the reasons that Stephen indicated, moving towards effectively this many-to-one relationship, many analytics clusters sourcing and syncing from a common object store. Okay, so with this architectural pattern, what kinds of Red Hat technologies are these early adopters using? Okay, so first, we're gonna paint this in the backdrop against 3 different inefficiencies, so addressing 3 different inefficiencies. The first inefficiency, as noted here, is addressing the cost inefficiency of scale of as you add more storage, 5 petabytes become 10 petabytes, becomes 100 petabytes, becomes several hundred petabytes, which is the case in many of these large shops. As you heard from Stephen, if you would attend the eBay talk yesterday, you would have seen adding more classic HDFS nodes results many cases in excess cost in idle CPUs because they come in a rigid node. You buy the HDFS node, it has compute and storage. Well, what if you just need the storage? So obviously addressing that cost inefficiency is if you need to add, so adding more storage should require the cost of adding more storage. So if you can decouple the analytics cluster from the capacity, your 100 petabytes turning into hundreds of petabytes, ability to scale that elastically, independently of scaling the costs of the compute layer. So that's the first Red Hat technology being used there is Red Hat Ceph storage. Red Hat Ceph storage, as most of you know, is sort of the most popular private cloud software that speaks the S3 protocol. And one of the things that actually makes this possible, this architecture possible actually, is thanks to the AWS community. The AWS community, because of AWS S3, worked with the Apache community and all the downstream Hadoop distros to ensure that the Hadoop S3A file system adapter was well supported. For those of you who follow that space, that's kind of the 3rd generation. The 2nd generation was the S3N. I don't remember what the 1st generation was. Doesn't matter. And so why does this work? Because there is a well-supported adapter that effectively, you can think of it as a protocol converter between HDFS and S3. And so for a lot of the analytics tools where you would have a fully qualified HDFS host name, instead of that, when you're referencing data, you would instead have an S3 endpoint. And so again, the first Red Hat technology being used by a lot of these early adopters is Red Hat Ceph storage, again being the most popular open source private cloud speaker of the S3 protocol. Okay, addressing the second inefficiency is effectively agility, this notion that Stephen referred to, the data scientist saying, hey, I've got a project, it may last a month, it may last a quarter, and I don't want to adversely impact the production cluster by running my experimental query. So I need to spin up a particular cluster that has the resources that fit the personality. So for instance, this is Presto. Presto, obviously, much more rapid response than something like a Hive on MapReduce query, and accordingly, the type of compute infrastructure underneath that is different personality. So not only do I want the ability to spin up an ephemeral compute cluster, but I want the ability to spin up the type of ephemeral compute cluster I need. If it needs more CPU, more RAM, I want to be able to twist those dials to spin up not only what I need, but specifically the type of infrastructure that I need. So addressing this inefficiency, being able to spin up multiple compute clusters. These early adopters that we were working with that I referenced before, all of them were using OpenStack for the on-demand provisioning of their compute resources. Interestingly enough, if you've been attending the keynotes the last couple of days, all of them are also evaluating OpenShift Kubernetes orchestration for the top layer in red as well. So today, they're using OpenStack, again, for putting in the hands of these teams on-demand provisioning of these, particularly data labs for data scientists. Tomorrow, they were, all of them across the board, looking at Kubernetes orchestration technologies such as OpenShift. So as a side note, one of the things that you may have been following at the conference here is there's a project now going in the upstream called radanalytics.io. You can hit that URL out there. It's effectively, it's a Kubernetes, it's a finer grain Kubernetes-based orchestration of analytics engines. So it's quite fascinating as Kubernetes reaches down and becomes effectively extends its orchestration capabilities to the big data world. So if you have interest in effectively what's been coarsely referred to as the containerization of big data, you might want to follow that radanalytics.io, again for the top red box. So that's addressing the second inefficiency in traditional architectures. Addressing the third inefficiency, and this is almost visually self-explanatory, as we met with these companies, this was one of their biggest drivers, was they had reached the point of necessity to respond to the needs of the business. They had not 1, 2, 3, 4, but handfuls of HDFS clusters, many of which had copies of the same data sets. So they said, hey, it's fine if the data set is a terabyte, but when the data set becomes, petabyte class, it's expensive to store lots of copies of these things. And so clearly, as reflective on the previous slide, there is, you can see in the top box in the analytics clusters, clearly there's, in particular, ephemeral storage in the HDFS nodes, transitory, whatnot. So, of course, you'd be copying up a portion of data sets frequently for the computations for the analytics itself. But in terms of full data sets, it was becoming very expensive to store multiple copies of those data sets as shown on the right-hand side. So obviously, one of their business drivers for going to this architecture was, hey, listen, I want to have a single canonical source of my big data sets that multiple analytics clusters consume subsets as needed on demand. So those are kind of the three different, reinforcing the three primary takeaways that we talked about at the beginning. The disaggregation of compute and storage as evident. The multiple analytics clusters, sourcing and syncing from a common object store. And number 3 is having those analytics clusters be provisioned on demand so that you can be more responsive to the needs of the, once you become successful, as Stephen mentioned, and they all come banging on your door and say, hey, this is good stuff, we want, in Stephen's finest British accent, please sir, may I have more? So when people come knocking on our door wanting more of this stuff, the ability to give them a little bit more flexible on-demand provisioning capability. So last slide, closing here, and then going into Q&A. And so where did we end up? So I mentioned at the beginning, we started this journey working with a number of large companies who were all adopting this type of architecture. We were learning from them. We actually brought in Silicon Valley Data Science to help us learn. And we wanted to stand up our own lab. So instead of just hearing word of mouth, we wanted to do this ourselves. So courtesy of Quanta Cloud Technologies, who are our lab partners, standing up a lab. We wish we had thousands of nodes, but it's 60 nodes. It's about 700 spindles. So in that lab, this is what we have. We have a series of query engines. In fact, the query engines that we're most using right now are Hive on top of MapReduce, likewise Spark SQL, likewise Presto. At the top, you see we designed the test cases. We didn't want to just use TerraGen, TerraSort kind of really kind of baseline benchmarking methodologies. We wanted, again, working with these three companies, we wanted to use benchmarking that was more representative of the real world scenarios. And so together with them and with Silicon Valley Data Science, we said across the industry, what are the benchmark utilities that are most reflective of real-world analytic workloads? And we came up, again, with these companies, selected the TPC DS, decision support. But it didn't scale enough for our needs, so Silicon Valley Data Science extended the TPCS benchmark suite. So that's what we're using up top. From a random object set data generation, we're using an extract from TPC-BB. That's the Big Bench data generation facility. So that tooling, in fact, it could be useful for you independently if you're looking for something to exercise your experiments as well. So this is Kafka on the lower left-hand corner. So this is the lab that we have set up. Some of you had asked beforehand, do you have the results yet? We're about midway through. We have some attractive, and particularly attractive Presto results, still working through some of the other Spark SQL, et cetera. So when complete, we'll publish, as always, in a reference architecture the results, but right now we're kind of still halfway through. So that's effectively what we wanted to report on to you, the work that we've been doing together with a number of early adopters and Silicon Valley Data Science. And with that, let's take the remainder of the time for Q&A, please. So I'll request, I don't know if Justin or Stephen, any comments on that. There were some, so it's not a 100% full functional compatibility. You are correct, and it's still not. Some of the things, if I recall, is copy object is one of the things. And interesting, most of the folks who are working with it, one of the interesting things that we pressed them on was two things. One was to your point, as well as the other thing was performance. That's the next thing that's probably going to come up is, okay, so what's the performance trade-off? So the general thing, we asked the same questions of these early adopters, is this sustainable from a performance and a functionality standpoint? And for the business drivers that we mentioned, their response to us, and we grilled them for, actually, we had 2 days, so 16 hours. We had some time to grill them. So similar type questions. So in their mind, they said the agility and cost benefits that we're receiving outweighed there was a performance trade-off. And again, that's part of why we have the lab, is we want to further articulate the performance trade-off. Side note on performance, interestingly enough, if you attended the eBay presentation yesterday, slightly different architecture, but also disaggregating compute and storage, also using Ceph at the back end, using some, in fact, complementing Ceph with Intel's cache acceleration software, found that it was almost parity in terms of traditional HDFS versus their architecture. So again, coming back to the point there and anticipating additional questions on performance, the business drivers were not, I want to do this because I want more performance. They were overwhelmingly addressing those cost inefficiencies as well as agility inefficiencies. So anyway, next question. There's another question out there. Varies by engine, but Stephen or Justin, you want to respond to that?
I'll go first and hand it over to Justin. So what we've normally seen, a lot of it will just really depend on the type of workload you're doing. There are, and I can more talk about S3 from a cloud standpoint than more from Ceph. The ideas are the same, is there are things that you can actually do to actually bucket the data in such a way that you can actually get parallel performance coming out of S3 that actually reduces that friction, as it were. But obviously it takes a lot okay, what am I doing? How am I going to separate this data and how can I pull it up literally parallel, where you're kind of pushing down to that layer to give me the data back as fast as possible in such a way, right? But there are techniques and it's trade-offs, right? Ideally, what you want to be able to do is, there's other people that, we've been looking at this a little bit, is predicting what that is to actually kind of warm up caches or warm up that data to get it closer to where you need it. Or like I've said before, in some cases, we'll pull the data up into HDFS or into a into a data frame in Spark, et cetera, because we know that that's going to be used all the time. We know we can do that. And then the cost is, if I need to go outside of that to go pull it, to Brent's point, the business cost outweighed having everything in memory at that point. Justin, anything to add? At all the layers, this is why I say security on these things is a pain, to put it mildly. There are things you can do. So it's kind of an interesting one. There's security at, say, the file level, system level, there's security. You got that in your object store and in HDFS. Then you potentially may have security at, if you're doing a, you're pointing the table to the files, which is pretty much what most of us do. Then there's security at that level about who can see what tables. Then potentially you have security at the row level as well. So there's like 3 or 4 levels of security. The question is how do they all play well together where I can start moving things around? That one it's being solved, but it hasn't been solved. At the moment, it's pretty much all or nothing. You just get all or nothing, and you have to be really careful. This is where we're seeing that when we have PII data and how we want to segment potentially between PII data and data that someone can actually see, and obviously doing encryption as well. Anything on your side?
Nothing
yeah, it's still work in progress, and what we're seeing is more and more companies are seeing like, okay, so this is now becoming real. Big enterprises are using it. We got to figure out what that security one is, and that's where I go back. If anyone could turn back the clock on Hadoop, for instance, the first thing we would fix is not use Kerberos. If you've ever had to put Kerberos together in a Hadoop cluster, and I have engineers with scars, it's really, really painful. There should be a better way to do it, and it's one of those ones. They want to use open source work. I can remember having conversations with folks when I was at Yahoo, and then afterwards when I met them at people from Cloudera or Hadoop or Hortonworks that I would run into and we would know each other. And they said, yeah, we really wish we wouldn't have used Kerberos, but it was open source and it made sense at the time. Well, that's it. There wasn't anything there at the time. It's one of the, it would have been better for them to actually create their own at that particular point in time. But security, they weren't thinking about that, oh, we can use Kerberos and go with that, right? It's one of those ones where it's doing it after the fact. The same thing to say is, why write a file system in Java? And by the way, I worked at Sun Microsystems for 10 years. I love Java. Why don't we just use C++ in that, just for that piece of it, just for performance? So there's a lot of questions you could say after the fact. And what we're seeing is some of these are actually changing and how they interact and work together.
Thank you for joining us today. So if you're interested in discussing our benchmark environment, we'll be happy to discuss it. We'll probably have room for a couple of additional, we call them kind of center of excellence type partners that we work collaboratively with your architects and architects on my team. Likewise, if you're interested in any of the benchmark modifications for TPC, DS, and BB or anything else, feel free to chat with Silicon Valley Data Science.
We can give it to you. It's pretty much open source at this point.
So thank you, Silicon Valley Data Science, for joining us today, and thank you all for spending your time with us.
Yep, thank you.